Part 2 Sample Problems. Step 1 Solve sample question number 1. Here's the question. An object has a mass of 100 kilograms. What is its weight on the surface of the Earth? We have both m and g. m equals 100 kilograms, and g equals 9.8 meters /s2, because we're looking for the weight of the object on the surface of the Earth. We set up our equation next. F equals 100 kilograms by 9.8 meters /s2. This gives us the final answer. On the surface of the Earth, an object with a mass of 100 kilograms will weigh approximately 980 newtons. F equals 980 N. Step 2 Solve sample question number 2. Here's the question. An object has a mass of 40 kilograms. What is its weight on the surface of the Moon? We have both m and g. m equals 40 kilograms, and g equals 1.6 meters /s2, because we're looking for the weight of the object on the surface of the Moon this time. We set up our equation next. F equals 40 kilograms by 1.6 meters /s2. This gives us the final answer. On the surface of the Moon, an object with a mass of 40 kilograms will weigh approximately 64 newtons. F equals 64 N. Step 3 Solve sample question number 3. Here's the question. An object weighs 549 newtons on the surface of the Earth. What is its mass? For this problem, we have to work backwards. We already have F and we have G. We just need M. Let's set up our equation. 549 equals mx 9.8 meters /s2. Instead of multiplying, we divide. Specifically, we divide F by G. An object weighing 549 newtons on the surface of the Earth will have a mass of about 56 kilograms. M equals 56 kilograms.
Part 3 Catching mistakes. Step 1 Avoid confusing mass and weight. The number one mistake people make on these problems is confusing mass and weight. Remember that mass is the amount of stuff in an object, which stays the same no matter where you move it. Weight measures the force of gravity on that stuff, which changes if you move through space. Here's a couple mnemonic to keep your units distinct. Mass is in units of grams or kilograms. Both mass and gram contain an m. Weight is in units of newtons. Both weight and newton contain AW. You only have weight while you're waiting on Earth, but even astronauts have mass. Step 2 Use scientific units. Most physics problems use newtons, N, for weight, meters per second squared, m/s2, for gravitational force, and kilograms, kg, for mass. If you use a different unit for one of these values, you cannot use the same formula. Convert to scientific units before plugging them into the standard equation. These conversions may help you out if you are used to the imperial/US system. 1 pound force equals 4.448 newtons. 1 foot equals 0.3048 meters. Step 3 Expand newtons to check your units. If you're working on a complex problem, keep track of the units as you work through your solution. Remember that 1 newton is equivalent to 1 kg*m/s2. If necessary, make that substitution to help you cancel out units. Example problem: Jeffrey weighs 880 newtons on Earth. What is his mass? Mass equals 880 newtons, / 9.8 m/s2. Mass equals 90 newtons / m/s2. Mass equals 90 kg*m/s2, slash m slash s2. Cancel units, mass equals 90 kilograms. kg is the expected unit for mass, so you arranged the problem correctly.